Karpathy went to sleep and woke up to an AI agent that had run 700 experiments on his own code and found a bug he'd missed. Today, we're unpacking why self-improving AI agents are the most consequential development nobody's watching, why the entire web is about to be rebuilt for software that doesn't have eyes, and the quiet fight over who owns the professional intelligence you've been training into your AI tools for months. From the team at the Synthetic Daily, it's Monday, April 20th, 2026. Good to have you with us.
We went through about 99 posts, articles, and threads across LinkedIn, Substack, and YouTube to find what people are talking about today. Let's get into it.
Here's a story that should genuinely unsettle anyone who builds software for a living. Back in March, Karpathy, one of the most respected ML researchers alive, former head of AI at Tesla, released a 630-line Python script. He pointed an AI agent at his own training code, gave it a single metric to optimize, and went to bed. 2 days later, that agent had run 700 experiments, discovered 20 genuine improvements, and cut training time by 11% on code Karpathy himself had already been tuning for months. It even found a bug in his attention implementation, not because the agent was smarter, but because it tried more things faster without getting bored after the 15th failed attempt.
And Nate Jones, who's been tracking this pattern closely, calls it the Karpathy loop, and the architecture is almost comically simple. 3 components: an agent with access to one editable file, a single objectively testable metric, and a fixed time budget per experiment. That's it. The minimalism is the whole point. By constraining the search space, you make the problem tractable for an AI in a way that sprawling systems never would be. A human researcher might manage 8 to 10 experiment cycles in a working day. The agent was doing 12 an hour.
But here's where it gets really consequential. In early April, a small Y Combinator startup called Third Layer took the same pattern and applied it not to training code, but to agent harnesses, the prompts, tools, and orchestration logic that determine how AI agents actually behave. A meta agent rewrote the task agent's entire scaffolding overnight and reportedly hit first place on 2 major benchmarks. Every other entry on those leaderboards was hand-engineered by humans. Jones makes a sharp observation. Optimizing training code is niche. Optimizing the harness, the system prompts, routing logic, tool definitions, that's universal. Every company deploying agents has a harness. And the auto agent pattern suggests those harnesses can be systematically improved by a meta agent that understands the inner model better than a human engineer could. The team even discovered that same model pairings dramatically outperform cross-model ones. A Claude meta agent writes better harnesses for a Claude task agent than for a ChatGPT one because it shares an implicit understanding of how the inner model reasons. Here's something that caught my eye. Jeff Dean, Google's chief scientist and co-creator of TensorFlow, dropped a stunning claim at GTC a few weeks ago. He said that making a model not 50 times faster, not 100 times faster, but infinitely fast would likely only yield a 2 to 3-fold improvement in actual productivity. Let that sink in. If the model is already 50x faster than a human at reasoning tasks, and we're only getting 2 to 3x back, where's the other 47-fold increase going? It's getting eaten alive by the human web.
Every timeout, every rate limit, every authentication flow, every pagination scheme, and every tool you've ever touched. All of it was calibrated to your pace. Your eyes, your hands, your coffee breaks. That was brilliant engineering for 50 years. It's now a bottleneck. NVIDIA's Billy Delley said at the same event that inference is now 90% of data center power consumption, heading toward 10 to 20,000 tokens per second per user. And those users are increasingly agents, not humans.
Nate Jones frames this as a 3-layer rebuild that's already underway. Layer 1 is making existing tools faster. TypeScript 7 is being rewritten in Go for a 10x speed improvement. Layer 2 is replacing the human tool interface entirely with agent-native primitives. OpenAI shipped persistent containers in February, where agents can install dependencies once and never restart between turns. Researchers published BranchFS, a copy-on-write file system with sub-second branch creation for agent experimentation. Layer 3 is the most radical, replacing all the human scaffolding around the web itself. Aaron Levy connected this directly to Dean's talk when he pointed out that every new generation of model effectively pinches off our human scaffolding in new ways.
The implications for the broader web are staggering. Coinbase agentic wallets have already processed over 50 million machine-to-machine transactions. Within 24 hours of launch, 10,000 new AI agents registered wallets on Ethereum. Stripe had to retrain its entire fraud detection system from scratch because the old signals were all calibrated for human shopping behavior. We're building a parallel web for a consumer that doesn't have eyes, and the companies designing its primitives, Coinbase, Stripe, Cloudflare, Google, are making their design decisions into de facto standards.
All right, next up, here's something that should bother every knowledge worker listening right now. Over the past year or so, you've been training your AI tools, ChatGPT, Claude, Perplexity, with your industry vocabulary, your communication preferences, your workflow patterns, and the behavioral nuances of how you actually think. Jones calls this your working intelligence, and he argues it's become a fifth category of professional capital, alongside skills, abilities, network, and track record. The difference? Every other form of professional capital lives in your head or your relationships. Your AI working intelligence lives on servers controlled by companies that have a direct financial interest in keeping it there.
That's a great point. He breaks it into 4 layers. Domain encoding, the industry knowledge you've dripped into your AI over hundreds of conversations. Workflow calibration, how you like research structured, code reviewed, memos formatted. Behavioral relationship, the unstated preferences your AI has learned. When to challenge you versus when to just execute. How technical to go when you don't specify. And finally, artifacts, the demonstrated capability of your thinking process, buried somewhere in 800 chat threads you'll never find again.
The incentive structure is brutal. No platform wants to make this portable. OpenAI, Anthropic, Google, they all make it easy to get context in and hard to get out. Memory is what makes these products sticky, and stickiness is the oldest play in Silicon Valley's consumer handbook. More than 60% of workers surveyed say they use their personal AI at work, often because the corporate-approved version doesn't know them. And when companies switch AI providers or you change jobs, that accumulated intelligence effectively vanishes.
So here's what I keep coming back to. Jones's proposed solution is a bring-your-own-context architecture built on MCP, the Model Context Protocol that's becoming a universal connector for AI. The idea is a personal context server, an MCP-native memory store that any compliant AI agent can discover and query on demand. You extract your working profile from the AI that knows you best, write it to a database you control, and expose it via MCP. It's not perfect. He estimates it captures something like 720p video quality of your full working identity. But it's fundamentally better than having everything locked inside a platform's memory system. The deeper argument is that we need to treat our AI context the way a previous generation treated domain names, as personal digital infrastructure worth investing in.
So let's jump to the big story. Jack Dorsey published a blueprint last week that got 5 million views in 2 days. The idea: instead of managers spending half their time synthesizing status and relaying priorities, what if software maintained a living, always updated model of everything happening across the company? Everyone queries it directly. Nobody waits for the Monday meeting. It's called a world model, and it arrived the same week Block laid off roughly half its workforce in the name of AI-driven efficiency.
Jones spent considerable time dissecting why this concept is both genuinely important and dangerous. The core insight is that managers don't just route information, they edit it. They decide what matters. When a system prioritizes, highlights, suppresses, or escalates, it's making judgment calls. And the failure modes are quiet. A revenue dip gets flagged as significant when it's actually seasonal. But the person who used to say ignore that, it happens every year, was removed in the last reorg. A correlation between a feature launch and a churn spike kills the feature, when the actual cause was a billing change that shipped the same week. The system can't distinguish correlation from causation, and nothing in the interface signals that distinction.
He identifies 3 distinct architectures people are building, each failing differently. Vector database approaches never draw the line between surfacing and interpreting. The relevance ranking becomes an editorial function no one intended. Structured ontology approaches, like Palantir's, draw the line too conservatively. They handle known relationships precisely, but are blind to emergent ones. And signal fidelity approaches, which is Dorsey's bet with blocks transaction data, create an illusion of judgment quality because the inputs are so clean. High signal fidelity at the input layer makes the system's interpretive moves look more trustworthy than they should be.
I was reading through this and, to me, the constructive takeaway is that any world model needs what Jones calls an interpretive boundary, a visible label on every output that says whether this is factual information the system is confident about, or an inference that requires human judgment before action. Almost every implementation he's seeing actively hides that distinction because the dashboards look authoritative and clean. And that, he argues, is an architectural failure, not a database choice.
There's a video making the rounds, over 266,000 engagements, from a creator who goes by the MIT Monk, and the core claim is provocative. Most people are using AI wrong because they're outsourcing their thinking and their brains are paying the price. He cites an MIT Media Lab study showing that people relying on AI for writing showed the weakest brain connectivity and recall. He calls it machine fog.
That connects to something else we saw. His proposed solution is a 4-floor intelligence architecture built on Google's tools. Ground floor, Notebook LM for grounding, because it only works from material you give it, your documents, your notes, your transcripts. It gives you the receipt, not just the response. Second floor, Gemini as a frontier model for exploration, with its 2 million token context window. Third floor, Gems as specialists, persistent personas that remember your domain, your tone, and your goals across conversations. Top floor, Google Workspace integration, where intelligence escapes the chat window and enters your actual work.
What's interesting here isn't the specific tool recommendations. It's the framework underneath them. The distinction between grounding and exploration maps neatly onto the interpretive boundary problem Jones identified with world models. Notebook LM constrains the AI to your source material, which prevents hallucination but limits discovery. Gemini opens up exploration but requires the user to steer. The system works precisely because each layer has a defined job and a defined limitation.
Yeah, and here's the thing. The broader point resonates with a thread running through everything we've covered today. Anthropic just launched its first official AI certification, the Claude Certified Architect, and the biggest chunk of the exam, 27%, covers agentic architecture and orchestration. That tells you exactly where the industry thinks value is heading. Not in prompting tricks, not in which model you pick, but in how you design the system around the model. Meanwhile, Gary Marcus flagged a Nature paper showing that LLMs may pass subliminal properties to other models. If a teacher model has hidden biases, student models can inherit them even after related mentions are scrubbed from training data. That's a reminder that the systems we're building are more opaque than we realize, and the case for human judgment in the loop isn't getting weaker. It's getting stronger.
All right, let's zoom out and talk about the bigger picture. were the main themes running through everything we covered today. The first big theme is the constraint advantage. From the Karpathy loop's single-file architecture to Notebook LM's source-only grounding, the most powerful AI systems in 2026 succeed precisely because they limit what the AI can touch, not because they expand it.
Next, infrastructure as the new moat. Whether it's agent-native web primitives, personal context databases, or world model feedback loops, the competitive advantage is shifting from model capability to the plumbing that surrounds it.
Next, the judgment gap. As AI automates information flow at every level, from code optimization to corporate knowledge systems, the most dangerous failure mode isn't wrong answers, but systems that present inferences with the same confidence as facts.
And the last one, professional identity as data asset. The accumulated working patterns locked inside AI platforms represent a new form of career capital that workers are generating daily, but cannot yet own, transfer, or even fully articulate. So if you're going to take away a few things from today's episode, here's what I'd remember.
Number 1. The organizations that win the auto-improvement race won't be the fastest. They'll be the ones that can define what better means clearly enough to hand the metric to a machine.
Number 2. Your accumulated AI context is now career capital, and unlike every other form of professional capital you've built, this one lives on someone else's servers.
Number 3. The most dangerous AI system isn't the one that gives wrong answers. It's the one that presents every output with the same calm confidence, whether it's reporting a fact or guessing at a cause.
And finally, we spent $1 trillion teaching Silicon to think, and the bottleneck turned out to be the pagination scheme on your CRM.
That's the Synthetic Daily for today. All the sources and links are on the website if you want to dig deeper.
Thanks for listening. See you tomorrow.
Bottleneck.